We want to know probability that it's at most one hurricane. That would actually be the other one. So equals Poisson, and we do the same x, and we do the same mean value, and this time we do true. So true, this means it includes 0 up to this number. So that would be 0 and 1. That's including, that's like what it says, at most one hurricane. It's probability of 0 hurricanes and the probability of 1 hurricane. Putting those two together. Wow, real good chance of 0 or 1. What else does we have? More than one hurricane. So how do we get that? More than one hurricane. This is always a weird one again. Probability of more than one hurricane. Well, in all the other ones, it seems like we had a certain number that could max out here, right? What's the most hurricanes we could have?
Unlimited, I guess.
No, we could have unlimited.
It's not really limiting us, is it? So that's interesting. Because there is no value of n. You notice all the other ones have that value of n? Here we don't even have that. Right? How many times are we doing this? Well, you could say 365. It's not like we have more than one hurricane in a day, but
yeah, but isn't technically that 0.6 is out of 100 years because it's in a century? It says during the 20th century, so that's like 100 years.
well, they used 100 years, but it's like the average per year. So yeah, we did use 100 years for finding that mean value. So maybe n is built into that.
Or, let me see.
All right, so anyway, we would do 1 minus this probability, which is 0 and 1, but then we of course have to add back on. So it's a lot like that last formula. All right, so I'll explain what these are. This is probability of 0 to x successes. And then this one is probability of more than x successes. Well, we'll show how these can be done with the formulas you can do in the calculator. And then